Okay, this video is going to do a review of working with exponents. So let's go over our exponent rules. First rule, when you multiply two quantities, we add their exponents. So for example, if you wanted to do x cubed times x to the fifth, look at how the exponents are kind of on the same level. This is when you're adding the exponents. So that's x to the eighth. Now be careful. It is not true to do x cubed plus x to the fifth does not equal x to the eighth. And that's a common mistake some students will make. When you're multiplying it, x cubed is x times x times x. You have 5 x's. Now I've got a total of 8 x's. When we divide, you can subtract exponents, but it's usually easier to think about simplifying the fraction. So for example, if I did x squared over x to the 7th, I've got 7 x's on the bottom, 2 x's on the top. I'll reduce the top and bottom by 2 x's. Gives me 1 over x to the fifth. Now if I subtracted my exponents, I'd have x raised to the 2 minus 7 to be x to the negative 5, which is equivalent to x to the fifth, but we usually want to leave our answers without negative exponents. Raise it to a power, we multiply our exponents. So x squared raised to the fifth would be x to the 10th. If you have more than one quantity, you got to raise each of the terms. So for example, and this is where it gets to be important. Let's say I had 2x squared cubed. Well, I've got to do 2 cubed times x to the 6th. I get 8x to the 6th. So numbers you're going to have to cube and do other things with. Okay, when you do get a negative exponent, like x to the negative a, same as 1 over x to the a. Fractional exponents, okay, this might be a little more newer for some of you. X to the a over b, the b tells you what kind of a root it is. It's the bth root of x to the a. This b right here is called the index. Right here is the same as the root, that's the kind of root you're actually taking. And then I'm raising to the a. Now, in practical usage, this is great when you're converting, but when we got to go evaluate it, it's usually actually easier to think of it this way. You take whatever the root is, and then you raise your answer to the power. We're going to look at an example of that in just a minute. A couple of special cases to be aware of. X to the 0 is equal to 1. Now, in every one of these cases, I'm assuming that x itself is not 0, because the rules just simply don't work when x is 0. Like 0 to 0 is undefined. Then, x to the 1/2 is equal to the square root of x. So if my index is 2, the denominator here is 2, it's the square root. So that's the other one you have to be kind of a little bit aware of. Okay, so let's look at evaluating fractional exponents. So I look over here and I see I have a 3 in the denominator. So it tells me I got the cube root of 27 and then I'm going to square it. So you take the cube root of 27. So I ask myself, what times itself 3 times equals 27? Well, that'd be 3 times 3 times 3. So this is equal to 3 squared, or 9. So let's do the same thing. I go, okay, square root of 25 is 5. So I get 5 cubed, that's 125. So it'd be real easy to go and evaluate those, as long as the numbers aren't too bad. But do the root part first. Because if I had to cube 125 first, that's hard. So you want to do the easier part first. Otherwise, numbers get too big. Okay, let's look at simplifying this exponent problem. So here's a couple of examples. First a product and then also a quotient. So we're going to follow our rules of exponents. So just like in PEMDAS, you do the exponent first before you do the multiplication or division. So I got to take raising to the power part first. So again, just like we said before, I get 2 cubed, a cubed, b to the negative 9th, 3 squared, 3 to the negative 4th, and b to the 12th. Notice the numbers are above, you kind of almost like distributing them in as you go. Now I'll simplify each of these. 2 cubed is 8. 3 squared is 9. So I'll multiply those together. I got 8 times 9 is going to give me 72. Then I got 3a's. Then I got negative 4a's, basically. So if I take 3 minus 4, I get a to the negative 1. B to the negative 9 times b to the 12th. Well, I've got 12, and I'm going to lose 9, so it gives me b cubed. And then this a to the negative 1, well, that's the same as 1 over a. So my final answer would be 72b cubed over a. Now on this one, I've reduced my numbers just like normal. 20 over 15, 5 goes into both of those. So I'll get 4 over 3. Now, what I'm going to look at in terms of negative exponents, this is a technique I like to use, and it's the safest one to use. Think of negative exponents like missing them. I'm missing 3 x's on top. I'm missing 2 x's on the bottom, missing 3 y's on the bottom. So I look at what I'm missing the most of on each of the variables. Well, it's 3 x's and 3 y's. I'm going to multiply top and bottom by x cubed and y cubed. This will replace the ones that are like missing. So I do x cubed times x to the negative third gives me x to the 0. Y cubed times y to the fifth gives me y to the 8th. Here I get x to the first, and I get y to the 0. Now, I know x to the 0 equals 1 and y to the 0 equals 1. So I get my final answer. Now, some of you may have been taught, well, let's move the x cubed to the bottom and the x squared to the top. That doesn't always work. And here's the case where you see that. If I had x to the negative 2 plus y to negative 1 over x plus y to negative 2. I can't simply move things around. But the technique of multiplying top and bottom by what I'm missing does work. So that's why that other technique is not necessarily the best. I have distribute, so I'd have x squared times x squared, negative 2, gives me no x's. I'd have y squared plus x squared, I lose one of my y's. And on the bottom, I'd have x cubed y squared, just distributing, plus x squared y to the 0. If you try to move the x squared, it's incorrect. That's why this technique is preferred. Okay, let's see about putting the ideas together, and we'll do a little bit harder one. Let me erase the ink on the slides and see what we've got. So we're combining raised to power, multiplication, division all at once. So again, I'm going to do the squaring before I do multiplication or division. So 6 squared is 36. I get a to the negative 4th, b to the 9th, b to the, yeah, so I'm going to get b to the 6th. Be careful of that one. Made a mistake there. 3 squared is 9, a squared, b to the negative 4th. Now, I'm going to start reducing so my numbers don't get too big. So 9 and 36, this goes in 4 times. I got 4 over 4, that becomes 1. Okay, I'm left with 12. Nothing else reduces it. I could have reduced it in a different order if I wanted to. Okay, now I'm going to multiply my variables going across. So a to the negative 4th, a to the 5th. That gives me a to the 1st, b to the 6th times b. I have b to the 7th. That's what's on top. On the bottom, a to the negative 3rd times a squared gives me a to the negative 1. b to the negative 2nd, b to the negative 4th gives me b to the negative 6th on the bottom. Well, I'm going to replace what I'm missing. So I'm going to multiply top and bottom by ab to the 6th. This gives me 12a squared b to the 13th. I replaced everything that was missing on the bottom, so that's my final answer.